Hi. So I'm Anya. I'm a student at UC Berkeley, and today I am going to go through some basic CS concepts for all of you guys. So the first one is a program for Hello World. So for this one of the most fundamental kind of concepts in CS is like the print statement. You use that to kind of help troubleshoot and understand what's going on. So for this one, it would just be print hello world, and then you would run it, and that would kind of be what comes out in the terminal. So when you're doing CS, there's two parts to what you're using. The first is the IDE, which basically is the interface that you're able to edit on. And then the second part is the terminal, which is at the bottom, which actually outputs the results that you are going to kind of be aiming towards in your IDE itself. So now that we kind of have shown like how to print in the console, we'll go into the next question. So this is an even or odd checker. So in this program, we want to basically use this modulus operator, which is very important because it kind of is able to check if a number is divisible by 2 or not. If the remainder is 0, then the number is even. Otherwise, it's odd. So for this program, what we're going to be doing is kind of using this operator to check if a number is even or odd. So for this, we have something called a function. A function is basically where we are able to run something and call it multiple times. It kind of helps with making sure that everything is kind of in one place and more organized. So if you have a statement, you don't need to write it a bunch of times over and over, but rather you would write it in a function and then call it later again. And then an important part of a function is the input and the outputs. When you're designing a function, you have to make sure that you think about what the input is, basically what you're putting in it, and the output, which is what you want to get out of it. So for this one, we're having the user give an input, which is enter a number. After this number is entered, we have a variable called num. A variable is basically just kind of an object that stores whatever you put in it. So in this case, the number that we input is going to go into the variable of num. So basically, the first thing that we have to do is see that if num is divisible by 2, and the output is 0, then that means that the number is even. So for example, if you have 4 divided by 2, the remainder would be 0, and that helps you know if the number is even or not. If you have an odd number, for example, 5, and you do the modulus operator, then that gives you a remainder of 1 if you're dividing it by 2. That kind of helps us understand the ability to do this. So now that I've run it, I get the function at the bottom, which is enter a number. If I put in 10, for example, that would output if the number is even or if the number is odd. If you want to try it again, we could use an odd number this time. If we try 13, this would tell us that the number is odd because the output that we get is not 0. Once again, another new concept that we understand is Another concept to understand is the concept of if and else operators. An if and else operator basically tells you that if this condition is true, then proceed with this function, versus if another condition is true, then go with that function. So in this case, what we would aim to do is see that if the number is equal to, if the remainder is equal to 0, then print that the number is even, else continue with odd. Once again, if you guys have, any questions or comments, feel free to type it in the chat. I'll be answering your guys' questions, and if there's something else that you want me to focus on, I'd be happy to go ahead and do that. Next, we'll be going on to our third program, which is the sum of numbers. So in this, the new concept that we're using is using a loop to repeatedly add numbers from 1 to 100. This is an important concept in CS of for loops. Oftentimes in CS, we're doing this to kind of automate things using computer program to make something speed up and go faster without us having to manually do it. A really important concept for this is for loops and basically how we would update a variable to kind of accumulate and get our final sum. So the first thing that we have to do is make a base case. A base case is kind of what the answer would be before anything actually happens. And so in this case, our total is 0 when we haven't started actually doing the sum. What we want to do is slowly keep going through the for loop and keep adding the numbers from 1 to 100. In order to actually, do this for loop and add all of these values, we have to make sure that it's going through a certain range. And the range in this case is the values of 1 to 100. So what we're doing here is first we're doing for I in range of 1, which is where it's starting from, and 101. The reason that we're doing 101 is because of the fact that range is not inclusive. So meaning that at the end, we're going to end at 1 before the number that we put in. So it's going to end at 100. And then what we want to do is append or add the value that we get from I into this total. So because we have our range number as the value or the variable as I is what we're holding it in, what we want to do is add that number to the total that we have up here. And notice that each time we run it, the total value gets changed. And that's kind of the purpose of having this value be defined before and then have it be changed each time we go through the for loop. Next, now that we have this, it'll start from 1, go to 100, and then we would just want to print what the sum is. And the variable that we're using to hold the sum is total. So now, if we were to run just this, let me comment out everything we've done before. Yeah, run this. This would give us a sum. So now if you kind of want to see how this would be able to work, what you can do is have it total be printed each time so that you're actually able to see how this is incrementing. So if we want to do a smaller number and actually see how total is changing each time, it shows how we start at 0 and then it goes to 1 and then 3, 6, 10, 15, 21, and how it keeps incrementing and changing the value of total as we go through this. Does anyone have any questions? Okay, cool. So we'll do one more problem before we, go to the questions. I see that Jay from TikTok asked if I could show merge sort. So now the next concept that we'll be looking at before we go to merge sort is how to reverse a string that's entered in by a user. So this is another concept called slicing. When you have strings, functions, or strings, integers, and floats, each of these are different data types. And within each data type, there are different functions that you can use to kind of analyze and extract insights from each of them. Something very important for strings is a slicing. So what we'll be doing here is writing a short program to reverse a string that's been entered in by a user. So once again, we're doing what we did before, which is taking in a user input. And let me go and comment these out. So the user will input a string, and then we have to figure out how we would actually be able to reverse the string using slicing. So there's syntax for slicing that includes taking in the word and then using this notation, the bracket notation, to reverse a string. So what we would do is put in the index that we want it to go towards. So as you guys know, when you're indexing a string, you start with index 0, and then you kind of increment up from there. So if you want to access the last note without knowing what the actual number is, you can use -1, and no matter how large the string is, we can go backwards from that. So once we have that reverse string, we just want to output this, and then we would be able to print it out. So if we have hello, it'll just reverse that, because basically what it's doing is it's using this slicing to take the last object, print that out first, and then go from there up until there's nothing left. I don't know if that makes sense. If you guys have any questions, once again, type it out in the chat and I'll be able to help answer. So now the next question that someone had was on merge sort. So I'll make another practice problem here for merge sort. So basically what merge sort is it's an algorithm that is able to sort a list of numbers. Or here's the problem that we're going to be doing. An algorithm that sorts a list of numbers in ascending order and use merge sort. So first off, what is merge sort? So this is the divide and conquer algorithm. The reason that we would use this over the other ones is to kind of help speed up the breakdown of how we're going through our list and array. So like how we did before, when we had a word, we kind of indexed it and went one by one. But if we have really, really long lists, it's inefficient to do that. So this is where we kind of look at sorting algorithms to figure out how to help break down our lists into smaller and easier to handle problems. So what this does is it divides the list into smaller sublists until each sublist has one event, has one element. And this is the most useful for sorting numbers. So if anyone has any questions, feel free to type in the chat to kind of ask me, and then we can kind of go from there. So what are the steps in this algorithm? So step number 1 is divide the list into 2 halves. For example, if we're using an array that's maybe 2, 4, 9, 4, 8, 6. And notice how these are not in order, you know? So the first thing that we would do is break it in half. So we do 2, 4, 9. And this is not the actual kind of how the algorithm works, but it's kind of the steps that you would have to take. The next thing that you would do is 4, 8, 5. So this is basically kind of the divide and conquer part. So when you have a list, you break it into 2 halves. Next, what you would do is sort each half. Basically, what this is doing is you're breaking down the problem so it's a little bit simpler, and you're able to look at each element on its own. Once you sort each half, you want to merge the 2 sorted halves back into one sorted list. And the reason that this is often tricky for people is because of the concept of recursion. The concept of recursion is basically a way to kind of run through cycles and organization, and then stop once it hits a base case that you want it to hit. This basically helps optimize the process of sorting and is very, very important in fundamental CS concepts. So now that we have the kind of basics understood of each, what we'll be doing, we can start writing out the function. So when we do have, each half sorted, we would sort this in order of increasing. And then we would keep going until each of these are on their own in an order, and then combine them back into one sorted list to get our final answer, which is a sorted list. So now obviously this is very useful for when the lists are larger, but for example's sake, we're using a smaller list, which is only 6. So now that we have this, we can start defining our function. So the way that you define any function is use the keyword def. Python has these keywords that if you use them in variables, they will error out. So you have to make sure you understand this can only be used when you're defining your function. Next thing you have to think about in any function is the input. So the input in this case would be the array that you are giving it. Next is we have to define our base case. Our base case is basically telling us like, okay, what should the array be at for us to stop running this function? So in this case, when do we want to stop going through the array? When the array has 1 or no elements. That makes us know that the list is already sorted and there's nothing we can do with it. Another key word for functions is the return. So a function kind of exists on its own, and if you don't actually give it anything to return, then the function is not going to give you anything back to use later on in your code. So making sure that you have return statements is important in any kind of variable or content that you want to give back in your function. Next, as we indicated above, is step 1, which is splitting the list into 2 halves. So what variable we'll be making for this is called a mid variable, which is basically, the middle of the list. So in this case, when you're giving a function, a variable, and you don't know how long it is, you want to basically be able to calculate the length without kind of hard coding it, which is giving it a number. So a very useful function, as we looked earlier, we saw range. Another one is len. Length basically gets the length of the array. So for example, if the array has 6, the len output would give 6. Versus on the other hand, if we were to use range would give you numbers going from 1 to 6. So in this case, we would use length because we want to get the length. Next, we would use this operator to kind of split the list in half. This is similar to the operator that we did earlier above, which is the modulus operator. So once you're able to split the list in half, you want to call each of the variables the numbers. So you'd have the left half, which takes in everything after the midpoint. And then you would grab the right half, which takes in everything before the midpoint. So as I did in an earlier problem, you were able to see how when you're doing slicing, you take in what's before, what's after, and then the things that you actually wanted to collect. So since we have the left half and the right half sorted, we want to basically keep doing this until we hit our base case, which is where our length is 0 or 1. So now is where the tricky part comes in, which is recursively sorting both halves. So what the recursion concept is that you keep giving the function that you defined to the new smaller, in this case, array that you're using. So basically what this means is what we're going to keep doing is when we have our left, we're going to run it through the same function again, so it can split whatever's already on the left into half one more time, and then one more time, and then one more time, until we hit our base case. And that's a concept of recursion. And so in this case, if we have our sorted left and we want to merge this and run it through our function, we would need to take the left half of our thing. So what would the input of this would be the left half. And then if we want to do the other side, it would be the same exact function, but with a different input of the right half. And then once again, the most important function that we have is to make sure that we merge the sorted halves. So in this case, we would need to return merge, sorted left, sorted right. And so now that the concept of this is having to merge the two functions with the final list that we have, we would have to, in this case, use a helper function to understand how to merge these two sorted lists. I think this helper function would be a little too complicated to explain, but if I were to kind of write it out in English, it would be exactly what we did up here, which would be taking in the left and right list and then comparing the elements. Basically what we did in our head here, which was seeing, oh, is 2 smaller than 4? No, put 2 to the left. Is 4 smaller than 5? Yes, put 4 to the left. Is 9 smaller than 5? No, put 9 to the right. That's essentially what this helper function would be doing with our given output from merge sort. So if anyone has any questions, you can type in the chat for that. But yeah, that's basically merge sort. The main concept in this is recursion, which involves setting a base case, which means this is where you kind of cut off the function and the function itself keeps running and running and running on this shorter input that you give it inside the function itself. So now I'm looking at the comments and there's another comment from Fanko, which is if anyone knows how to code in MATLAB. So MATLAB is typically used for more mechanical engineering rather than software engineering. And this is going to be covering software engineering for now. So yeah, now we can keep going with the rest of the content and questions that we have planned. And the next concept is looking at factorials. So in terms of what a factorial is this is a product or multiplication of all integers from 1 to a given number. So for example, if you're doing 3 factorial, then that would be 3 times 2 times 1, and that would give you 6. So basically in this case, what you're doing is kind of going backwards from the final number and then going down all the way to 1 and then multiplying all of those numbers together. So now in terms of how we would do this is the concept that we learned in the previous problem is recursion. This is basically where a function calls itself to calculate the next number. In this case, we have to first define what our base case would be. If anyone remembers from last time, the base case is essentially where we know that the function is over and it's time to end it. So in this case, if the number that we're given is 0, we know that it's time to end our factorial and just return the value of 1. And then in terms of the actual math that we'll be doing, if we're looking at the value of n, which is the number that we give it, so for example, if that's 3, and then we're multiplying it by the factorial of the number that's 1 below it, that would be n minus 1. If you want to kind of think about this in English, the number that we're taking in is 3, and then we're multiplying it by the number that's 1 less than 3, which is 2. And then we check the next value. Is that value 0? No, it's 1. So then once again, we go back here, we do 2 times factorial of n minus 1, multiply that, and then that will give us 6. Essentially, this concept of recursion is looping through a function, except you're changing the input value, and you're saving that somewhere else. In this case, what we're doing is using n as our input value, modifying it every time, and then using that to help understand what we're doing. I see someone in the chat said, can you go over how to input a file? And yeah, we can go over that. Once we do this palindrome checker, which I think is very similar to the previous one, we'll be able to then go into looking into how to input a file. So now if we have our palindrome checker, we want to write a program to basically check if a string is a palindrome. Just for some context, a palindrome is a word or phrase that reads the same backwards and forwards. So for example, like race car, RACECAR, that is the same forward and backwards. In this problem, we would also be using the same concept of slicing to check if a string matches its reverse. So the first thing that we're going to do is once again take in our user input. In this case, we're entering a string to check if it's a palindrome. If we were to run this, we would put in a string, and then once we have our function, it'll be able to actually run it on this. So in this case, we have to look at, once again, what are we inputting? Our input is the user input variable. We want to look at the user input variable and see if the first letter is the same as the last letter. So now earlier in this session, we looked at how to slice and get the last word or the last letter of a word. And that is basically the same thing as taking in the user input before and the user input basically, which is the last letter. So what this does is it keeps going through it, slicing it one by one, and if it matches every single time, then that means that it would be a palindrome. If that's not the case, then we just have it print not a palindrome. Yeah, if we were to try this again with a word that's not a palindrome, then that would show that this is a word that would not match up with, like each letter would not match up from the beginning to the end. Okay. Now for our next question, which is looking into how to input a file. Let me prepare a small sample file that we could use. Actually, since we're using a local IDE, it wouldn't be able to actually access our desktop. So then I think we'll just keep going with the problem we have here. So in this one, we're looking at the largest value in an array. So what we want to do for this is take in the largest number in an array and compare that number to everything that came before it in a for loop to try to figure out what the largest variable is and updating this largest variable number with that number depending on if the number is larger or smaller than the one that came before it. So what we're doing is first we'll define our function of numbers. In this one, we take in an integers 4x in the input of whatever numbers that they want. So for example, if the user gives in the number 10, we would then go through each value ranging from 1 to 10. Next, what we would do is define what we want largest to be. So this is kind of like a base case again. So in our array, we would take in the first value that comes in and use that to keep track of our numbers array. The next thing that we would do is, as we're going through our numbers, we're going to do for num in num. So basically the concept of for num in num is how we iterate through an array. Num could be the first one, and then it goes on to the second one, and the third one, and the fourth one. What this does is it just goes through the contents of the array one after the other. If the number that we're looking at is larger than the number that we have here, which is basically the 0th index in the array, what do we want to do? What we want to do in this case is replace that larger number with the number that we just looked at. So in terms of like an example, if we had an array of 9, 1, 3, 12, 2, 1. What we're doing is basically first putting our pointer at the index of 0. So first we're putting our pointer at 9. Then we go, okay, let's go through numbers. For num in numbers, if that is greater than largest. So if we have 9, is 9 greater than 9? No, we keep going. The next one in the loop would be 1. We're looking at 1. Is 1 greater than 9? No, it's not. So then we keep going. Is 3 greater than 9? No. Then we go to the fourth one, which is 13 greater than 9? So in this case, largest is stored as 9, but 13 is bigger. So what we have to do in this if statement is kind of figure out how we would replace this largest with the new number that we're looking at. In this case, what we do is set largest equal to this number. So if that makes sense, what we're doing is, as we're looking at this, 9, 1, 3, 13, 2, and 1. Once we get to 13, we set largest equal to 13. Then that means that once we finish going through this loop, comparing 13 to 2 and 1, our final answer of largest stays at the value 13. That's basically how we would go through a for loop and compare all the values to one another to achieve the one that you are looking for. Now, our next example is also a pretty important concept in computer science. So when we have object-oriented programming, what we're doing is basically grouping variables together in this concept of classes. So what we're doing in a class is basically seeing how to kind of make variables that are correlated to each other and have these like objects basically have their own instances and attributes. An instance is when you basically create a class, and an attribute is the variables and the methods that are associated with it. So in one example that's pretty common is we'd have students and classes. What we would do in this case is look at a class called students, and we would want to basically give each student an attribute and a grade. So the special thing about classes is that you can basically use it as a template. So when you have a template of a class, you can use it later on to create multiple students that have the same attributes. So for example, if you make a student class, you would say that, okay, every person or every object that's a student must have a name and a grade. And what you can do is make multiple names, multiple grades for each object. So the first thing that you do when you're making a class is you use this class function. So once again, as we learned in the past, using functions and words like def, for, and so on are kind of words that you use to define things. Class is also the similar word. Along with that class object, there's a way to define it, which is this function called def_init, which is basically initializing. So what you're doing in this is you're initializing the object by referencing itself, and then also referencing in the attributes / objects that you want it to belong to. So what we're doing in this case is, since we wanted to have the attributes of name and grade, the first thing that we're doing is making sure that the object actually is able to take in the name and the grade. As you've discussed before, an important part of functions is the inputs that you give it. In this case, the inputs that we're giving it is itself, the name, and the grade that it belongs to. So then what we're doing is we're basically defining each of these. So if we have self.name, we want it to basically take in the name that we're giving it. And if we have self.grade, we want it to take in the grade that we're giving it. So for example, if we have a student named Bob, we would make a call and create a class that has Bob, and his grade might be a B. So that's basically kind of how we would make a student class and define the attributes that belong to it. The next part of making a class is the functions and methods that belong to each class. So in this case, if we have a method that we're printing the student's details, the first thing that we would do is take in the object that it wants, which is itself. So in the concept of classes, when you have a method, you need to make sure that you understand which object it's actually pointing to. And by having the self be an input, that helps draw the arrow to point this. As we're going through this, we basically see how the syntax would look if we need to call the name and the grade. So if we're printing something, we have to include an F to kind of indicate that there's a special notation that we're using, which are these brackets, since we don't want it to print these brackets and actually print the name and the grade itself. So if I uncomment these, we can actually try it out and see what it would look like. So now after we've defined everything, we want to make sure that we know how we would actually call this. And the way that we would do it is basically define the student as a name and the grade. I don't know if anyone in the chat wants to give a name and a grade example. If not, I can keep going. So kind of as I said before, if we have Bob and his grade is an A, we would basically run this. And when we print the details, we get exactly that. We get Bob and we get his grade. So if you want to modify this to not be either of these things, we could just have it print out the name and the grade. So that's exactly what would come out of this. If we want to try to make another student, and then we can name her Alice. We can do student Alice dot print details. Yeah, so basically now what we're doing is, since we instantiate a class, within each class, there are attributes and there are methods. The methods are the functions that belong to each class. And from there, we basically are able to create multiple objects of the same class and print out all the details for them. Now we'll keep going and do some more examples of these, as this is a pretty important concept and difficult to understand since it's slightly abstract. We're going to be doing another example, which is using cars. So what we're doing is going to create a class to represent a car with attributes of make, model, and year. We'll also add a method to display the car's year. So a problem like this would be really useful in real life. So for example, if you're working with a company that has a database of all of their car registry and information, this is kind of how you would make it streamlined and organized so that each car has a set of attributes and you don't have to keep defining a variable to hold it every single time. The first thing that we would do, as we did above, is define the class. So this class has a name car. Next thing I would do is use this initializing function. This is very, very important, and each time you make a class, you have to make sure you include that. And the next thing that we do is pass in itself so that it's known how and who this object is referencing, which is the class reference. Then we take in the three attributes, which are make, model, and year, and we define them just as we did above. Self.make equals the make that we give it, self.model equals model, and self.year equals year. So now that we have our attributes instantiated, what we want to do is make our method. So in our method, we basically call what we want our method to be. A method is another way to say function that belongs to a certain class. So in this case, our function is display details, and the class that it belongs to is itself, which is the car class. Also note that when we do indentation, that means that the functions and the methods belong underneath the position that we put it at. So basically, by indenting these and putting them under the class car, we're basically saying that these belong in that class. So once you have the name written out, we get to decide how we want to print out the year of the car. So when we're using and calling these variables, we have to make sure that we put self in front of it so that it knows to get the one for its certain object. If we did just year in this function, it wouldn't know which year we want. As for example, if we did up here, if we did student.grade, it wouldn't know which object, the Alice object or the Bob object, to get the grade from. Now that we have these, what we want to do is create an example usage of our cars. So if we want to make it a Toyota model, and then the year, and then have it try to display these details. Then our output would be car 2020, as we've defined our function of display details to be the year that this car was made. Note that you have to make sure that the variables match up precisely when you're doing these outputs and these functions, or else it's not going to show the correct one. Also, once again, as I mentioned before, this F statement is important as it makes sure that we're able to get rid of these brackets and output a clean result of the car. We'll do one more complicated car problem, which has more of operations, as you can see how these classes are used in real life again. So this problem is going to be looking at banking. We're going to basically make a bank account with attributes such as the account holder, the balance that's in it, and then once we have the account holder and the balance, we're going to be basically making a method to deposit and withdraw money. So basically this is new than compared to what we've done before, as we're actually making changes to the numbers that we put in. And this is exactly how in real life we would be making these modifications. So these methods that we're using would be deposit and withdraw. Exactly how money would be exchanged in real life. Once again, we're going through the same process of how we defined this before, where we make sure we initialize our class and give it the attributes. In this case, we have two attributes, which is the account holder and the balance. And something new that I'm introducing now is the concept of setting a null variable. So what we're doing is we want to give this a standard balance that it always takes on or always begins with. And if you have a bank account, you have to think about what is the balance that it's always going to start with, which is 0. So once you've kind of set this, you can go into exactly what you want these objects to be. In this case, we have to make sure that it references itself and it takes in the account holder name and the balance in the account. So we could have this balance be whatever we define it, as we've done before with like defining our grades or defining the car class, but this is just kind of an easier way to understand it. The next thing that we would do is define our deposit and withdraw functions. So what we're doing when we're depositing is basically putting in money. And what we did here was create a new variable. This new variable is called amount. What we're doing in amount is giving the amount that we added to our deposit. And then what we have to do is make it a positive add to our balance and also make sure that we redefine the amount to be what was added in. And then we would want to print exactly what the amount is. Once again, using our f-string notation. And the same thing that we did for deposit, we similarly want to do for withdraw. So in withdraw, except this time it's going to be a negative amount that's get added. So we're basically going to be subtracting. If amount is greater than the balance, then we want to make sure that we're not able to withdraw that, because if we're asking for more money than is actually in the bank account, there's nothing that we can do about that. So once we kind of have that base case, basically where we check, we then go into the next part of it, which is looking at the else statement. This is basically just what we do when all is good, there's enough money, and we can actually subtract and equate that new amount. Something else that we would want to do when you're considering problems like these is the actual user interface. Since we've told how much has been withdrawn, we can also tell them how much their new balance might be. So now that we've defined both our instance along with the methods that we would use on it, we can then go into the example usage of how we would call this. So as we've kind of done in our earlier problems, we would define what we want our variable to be and create an instance of that. So for example, if we're making an account or a bank account, we would say what we want the name to be and the amount that we wanted to start with. So just that itself, adding maybe 10 or 100, we can then see what the output would be. Yeah. So we have 100 deposited. And what we want to do is also add a comment for this to show what the new balance is, as we did before. The reason that this would work is because over here, we're updating the self.balance amount with what we need to include. So since it started out with 500, we added 100 in our deposit. It said that we deposited 100 and then our new balance is 600. Also note that when you're using the same object, you can make constant changes and it'll keep updating the memory that it had before. So now, for example, if we wanted to withdraw 550, it would withdraw it from the 600 amount and give us 10 left over. Or 50, my bad. So 600 minus 550 would give us this new amount. So that's an important thing to note when you have the same object and you're doing all of these operations on the same object. That would keep in its memory the previous results. Now, before we end, we'd kind of do one last problem. Something that I did want to mention is we have a QR code on the screen for any of you guys to reference if you want to subscribe or get any more information about Chegg and its tutoring. That would be super great to check out. So now for our final example, we'll have this be sort of short and talk about a new class that we'll be building for dogs. Here we would want to experiment a little bit more with the methods and kind of be able to see how the objects can actually interact with each other. So what we want this to be is have the attributes of the dog name and the breed, and we want the method to be the dog barking and fetching. So now what we'd be doing here is, once again, instantiating the class, where it'll be taking in itself the name and the breed, and setting these variables to each other. And next, for the method, the first one that we want to make, what's that? I forgot to define the class. So the first method that we want to make is the bark method. What we'd be doing here is passing in itself as an object and indicating what we want to happen when this happens. So what we can do is have this dog print bark, and then we can say that this dog name says bark. And then if we want to do fetch, something else that we can do that we've done before is kind of help and try to involve new objects that come in when we instantiate a method. So in fetch, we would not only pass it itself as we usually do, but also an item that we want it to go fetch. So for example, we would have it print this dog is fetching this item. And then once we have all of these defined, just to reiterate, we have our attributes and our methods. These can get extremely complicated, so making sure that you have everything written out in a good way is the most important thing to set yourself up for success as you're kind of building larger and larger classes. Once you have this class written, you want to make sure that you have the usage that you want it to go with. So, for example, if I want to name this dog Sparky, I would make sure that I call the dog class. I would give the name Sparky and the breed. And then understand that once I have this class, if I want to actually call any methods on it, I'll be able to do that by doing the object dot the method. Yeah, so over here we say Sparky says bark. And then if we want to try another one, yeah. So notice how when I called fetch, it didn't let us work because we were missing a positional argument, which was item. So now say that I wanted a default. For example, I wanted a default item to be ball. I could set that up in my actual fetch function so that if nothing is passed, then the default is ball. Say I wanted to actually give my own item. I wanted to say he fetches a stick. Then what I could do is put in the stick, and then it would override the default and actually present the stick. So if that makes sense, you guys can use this to kind of build your own classes and your own functions. So I noticed that someone, Derek, had a question, which was, why do some functions need self? So self is needed as the first parameter within a class because it represents the instance or that one kind of example that is calling the method. Self lets people access the attributes or the variables within a specific instance of a class. For example, you could make multiple dogs, but when you're calling Sparky, you want to make sure it calls the attribute on Sparky itself and not a different object. Without self, the method would not know which object's attributes it should refer to. I hope that helps. But yeah, thank you so much for coming and joining our live stream. Once again, we have the QR code in the corner. Yeah, see you guys next time.